Hello, everybody, and welcome to this Climate Farm demo webinar. I hope all of you can see the screen and hear me correctly. We are here for Climate Farm demo project funded by the European Union. This project involves more than 60 partners around Europe and around 1,500 demonstration farms, pilot demonstration farms. My name is Benoît Rouillet. I'm working at the French Livestock Institute, which is called idele. And for Climate Farm Demo, I am your thematic leader about feed additives for reducing methane emissions. We already had one webinar in the past for general information about how to measure, predict, and reduce methane emission of bovine. And we're here today to have an update on feed additive research, specifically in pasture-based dairy systems in Ireland. So we will, in a few minutes, welcome our two speakers from Teagasc in Ireland. The first thing I would like to mention for all of you attending this webinar is how to use Click Meeting. So please choose the right browser. You can attend the webinar with Chrome, Firefox, or Opera. In case you have a sound problem, please check your internet speed to see if it's not enough to receive the sound. You may attend by phone. And so you will have the number of the phone number in the invitation you receive by email. Display your browser in full screen. You can click at the top right of your browser on full screen. You have the chat. If you have any question during the presentation, you can write it in the chat box. I will do the moderation and I will provide the question at the end of the presentation. We will have a time for exchange. And of course, in case there are a lot of questions, I will make a selection. Presentation is recording, so the webinar will be available soon on the YouTube channel of Climate Farm Demo. So you will be able to find it there and to spread it. And so if you have any difficulty using Click Meeting, you can ask Susanna in the chat using her name with the arrow base. All this information are also copy and paste in the chat, so feel free to go back to this information as when you need it. The first job for you who are attending this webinar is to fill a short one-question survey just to know who you are. So please, a few minutes to answer this first question. Susanna, you can choose when you want to close this survey. Maybe a few seconds. No, okay. So most of you are researchers, but also we have a quarter of advisors and a short part of others. No farmers, unfortunately, but we will try to do better in the future on different topics. So we will move to this webinar, and we are very happy to welcome Ben and Hazel from Teagasc, and they will give us an update of the research on feed additives and specifically on pasture-based dairy systems in Ireland. And I'm very happy to have them. So Ben and Hazel, the floor is yours.
So, thanks very much, Benoit. Myself and Hazel are going to go through an update on the research that's ongoing on feed additives in pasture-based settings in Ireland, and to just give it a brief introduction on some of the other research we're doing as well. So just a brief introduction myself. My name is Ben Lahart. I'm a researcher working on enteric methane emissions. Hazel, do you want to just give a brief introduction in yourself?
Yeah, so my name is Hazel Costigan, and I'm also a researcher working in Teagasc on feed additives to reduce methane.
So yeah, thanks very much, Hazel. So we'll just go through, I suppose, an introduction and I suppose some of the challenges Irish agriculture is facing in terms of reducing its emissions. So Irish agriculture has been set a target to reduce its total greenhouse gas emissions from agriculture by 25% by the year 2030. So that's relative to our reference year in 2018. So we have a number of different solutions. So we've developed a marginal abatement cost curve, which can be used to implement different strategies. And some of these strategies, such as improved animal breeding, can be implemented already, and these can, reduce the amount of emissions on farms in Ireland. So that's phase one that can be implemented very, very easily. And then if you move through the different phases, there's other different strategies then that, they're almost ready. They're almost ready technologies such as feed additives indoors, changing the type of fertilizer farmers are spreading, moving towards protected urea, and slaughtering their animals earlier if they're in a beef system, which will reduce the amount of methane produced over the animal's lifetime. And then if you move on to phase three, early stage technologies, you have the development of feed additives at pasture. So the majority of our systems in Ireland are pasture-based settings where animals spend the majority of the year grazing. So these additives have to work in a pasture-based setting to get a substantial reduction in methane emissions. And then the final area is breeding or genetically selecting animals to be lower emitting animals in terms of their enteric methane emissions. So they're at the early stage. And with all this research, the target is to utilize it to get to that reduction in emissions by 25% by the year 2030. So that's, and then moving on to 2050 to get to climate neutrality. So if we just go on to, I suppose, the key areas in Teagasc's climate strategy. So there's three key pillars, and these are broken down in the slide here. So the first pillar is the Teagasc Climate Centre. So this is a virtual centre that was developed to, I suppose, accelerate the research capacity for environmental, I suppose, areas in Teagasc. So it's a virtual centre combined of various researchers around Teagasc, and it's all kind of leveraging off one another and utilising ideas and getting the most out of the system in Teagasc, so we can make big gains in terms of the research. The next thing then is to be able to quantify any emissions reduction. So that's the use of it's a digital tool that can quantify greenhouse gas emissions on farm. It's called AgNav, and basically this tool can give an individual farm an individual number in terms of a greenhouse gas emissions profile, depending on what practices the farmer is implementing on their farm. So if the farmer is implementing strategies such as altering their fertilizer type or reducing the amount of fertilizer they're spreading, or slaughtering their animals earlier if their beef system, or even feeding a type of additive in the future, they can get credit to the AgNav system and reduce the amount of emissions on their farm through the portal. And then the final area is the signpost advisory program. So this is a new program that was developed with the view to disseminate all this research coming on stream from the likes of the Climate Centre and the information from AgNav, and utilise AgNav to reduce emissions on farm, and to really, provide farmers with a distinctive voice and a dedicated service and tool to reduce emissions on farm. So that's I suppose the three key pillars in terms of what Teagasc is doing. And then if we just move on to, I suppose, agricultural emissions profile and break it down a bit more and look into it. So because majority of, there's a lot of ruminant livestock in Ireland, pasture-based settings, the major greenhouse gas emission from our systems is from enteric methane. So that's methane emissions from, the ingestion and digestion of forage, primarily grazed grass, and that accounts for approximately 65% of agricultural emissions in Ireland. And as I said, there's a 25% reduction in emissions required by the year 2030 relative to 2018 levels. So ultimately, being able to develop solutions to reduce enteric methane emissions is going to be very important to help meet these targets. So the objectives of the research we're doing in grazing systems is to improve the understanding of enteric methane emissions in these systems and develop solutions to reduce enteric methane output. So the primary area we're going to discuss today is on feed additives to reduce that, but initially we'll just give a flavour of some of the other research we're doing on enteric methane emissions. So how we're measuring methane is using a green feed unit, and you can see this unit here in the picture. So this unit basically measures the amount of methane cows produce by enticing them to go and visit the unit. We just go to the next slide here, actually just gives an overview. So this cow here has her head in the unit. She's getting a small amount of concentrate feed over a 3-minute period. Her tag has been read. And basically the air from the animal's breath has been sucked into the system and it's going into a CO2 and methane sensor there in the system to give a reading of how much methane that cow produces anytime we visit it. And these machines, they're trailer mounted, as you can see. They can be powered by the sun, and they can be adjusted for external conditions such as wind speed and direction. We can't use these green feeds to measure methane emissions or any type of other equipment such as respiration chambers to measure methane emissions from livestock, on farms, anywhere in the world really. So we have to use calculation models or prediction models to, I suppose, back calculate the amount of enteric methane animals are producing. So in Ireland and in our research, we're putting a big focus onto improving these prediction models. So at present, we're using a model developed by the IPCC 2019 under their guidance. So this model is shown in the graph here. And what this does basically is it predicts the gross energy intake of a cow within a specific region in Ireland. So a specific dairy cow within a region in Ireland, such as Munster, which would be in the south of Ireland, would have its gross energy intake predicted based on how much milk the cow is producing, that average cow is producing, how heavy she is, and what stage of pregnancy she is in. Multiply that by the methane conversion factor, which is the amount of methane assumed that the cow is eating, the amount of feed the cow is eating, assumed being digested and belched back out again or eructed as enteric methane emissions. So a big thing what we're trying to do is to see how our actually direct measurements from these green feeds and from our measurements compared to this methane conversion factor and total methane produced across the season. So what we found is that the methane conversion factor for grazing cows actually has a seasonal nature to it. So this is a study we've published in 2024, and basically this shows that the amount of, for every unit of gross energy intake consumed by the cow, that actually the amount of methane been lost per unit of gross energy intake actually changes across the season. So you can see in the graph there, in springtime it's actually quite low at about 4.6%. In the summer then it increases to 5.3%, and in the autumn then it peaks in this study at 5.8%. So it's a seasonal nature to it, and other researchers have found this in New Zealand and in the Netherlands, that as you go over the grazing season, the amount of methane actually changes depending on the type of grass the cows are consuming. And it's likely due to differences in sward quality, because in the springtime in Ireland the grass is very, very high quality. Low levels of fibre are highly digestible, and that can lead to lower levels of enteric methane emissions. But on average across the year, the average methane conversion factor, in this study is 5.2%. So that's substantially lower than that figure used by the IPCC and using our inventory in Ireland at that 6.3%. And we look into putting these updated methane conversion factors into models and comparing them to the model emissions or calculated emissions. You can see there's a big difference there, especially in the springtime. There's about a 40% difference between the measured methane and the calculated methane. And then it gradually kind of diverges over the grazing season, and it's similar by the autumn time. But on average in this study, the enteric methane emissions were overestimated from the cows by approximately 18%. And it's important to note that that's one experiment. So we have a number of different experiments done using a number of different techniques over the last number of years in Ireland, over the last 20 years, using the sulfur hexafluoride techniques, SF6 technique, respiration chamber, and green feeds. And when you look at average the methane conversion factors from all these different studies, the value is about 5.8%. Is average is 5.8%, and that's 8% lower than that value that we're currently using in the inventory, and that's recommended for grazing cows. So what that means is that at present, when we use this 6.3% in models in Ireland, the average enteric methane output is approximately about 355 grams per cow per day. Whereas when if you use updated values, it would be closer to about just over 310 grams, 315 grams per day. So this research then can be used to refine the enteric methane conversion factor for dairy cows in Ireland, and so we'll have a more accurate starting point to reduce from which to reduce our emissions. And then we're going through different research areas that we're looking to reduce enteric methane emissions. So these are mapped out here. We have animal breeding, grazing management, and feed additives. So I'll just briefly touch on grazing management and animal breeding. And then Hazel will discuss the feed additives. So the first area to talk about is pasture. And one thing that can done on farm very easily is to reduce methane emissions, to actually utilise spring grass. So farmers can, in seasonal calving pasture-based settings where cows are calving down in earlier in the year, if they can get their herd to calve down earlier in the year and get the herd access to grass, that can reduce the amount of methane being produced by the herd. If you minimise the amount of silage going into the system, you can also reduce methane emissions. So making sure you have enough grass on the farm during that spring period and utilising it can reduce the methane emissions profile. So you can see that graph there. March, April, and May, there's substantially lower enteric methane emissions compared to as you go into June and July, it begins to increase. In the summer months, then methane will increase, but that can be offset by ensuring the animals are grazing high quality pasture. And to do that, the farmers need to ensure that the pre-grazing herbage mass or the sward height, the height of the grass the cows are going into is at a low enough level to be about 8 or 9 centimeters or 1,500 kilos of dry matter per hectare above 4 centimeters. And what this will do is reduce the amount of fibre the animals are consuming. As you can see that graph on the bottom, there's a positive relationship between fibre content, neutral detergent fibre, so it's an indication of how much stem is in the sward, and the amount of methane produced. So if that can be reduced, it can reduce the amount of methane produced. What I suppose the next element of that's a very effective way to reduce enteric methane emissions, but to be calculated in the likes of carbon footprinting tools or within the national inventory in different countries, you would require forage quality or feed quality data to be able to back calculate the effects. So you need the information on the quality of the grass the cows are consuming. So that's, I suppose, a research area that's required. In different countries around the world, some countries can, especially indoor settings, can collect data on forage quality the animals consuming, so they're able to back calculate methane emissions. It's more difficult to do at grass, so this is an area of future research. Last area I'm just going to talk about then is just on animal breeding. And animal breeding can be a very effective tool to improve any trait within any given system. So in dairy systems in Ireland, we use the economic breeding index to genetically select cows for the next generation. So this breeding index was introduced in the early 2000s, and it's an economic index. So basically it means that as farmers use it and improve the economic value of their herd, they're going to increase the profitability of the herd. So the breeding index is called the EBI, Economic Breeding Index, and what it would mean is a farmer who would have a higher EBI, it's measured in terms of euros, they should have higher profitability. And for every euro increase in EBI, a farmer should see a €2 increase in profit. So we've thought it was very important to evaluate the effect of EBI or improved genetic merit from dairy cows on enteric methane emissions. We had two groups of cows. We had an elite group in this study, and we had a national average group, or NA, and there was a €100 difference in EBI, and that should lead to a €200 difference in profit. Higher EBI group were more productive. As you can see here, they produced more milk solids. So there was no difference in milk yield per se, but there was a higher percentage of fat and protein, and that led to higher milk solids. And that actually should lead to higher methane output. But the measured methane output, as you can see here in the table, there was no significant difference. And what that meant was that when you related the amount of methane produced per unit of milk solids output, because these higher genetic merit cows were more productive to produce more milk solids, at a similar level of methane, there's dilution of the amount of methane they're producing and less methane produced per kilo or per unit of milk solids output. So they were more efficient. And another interesting thing that was found in this study is that when you calculated the amount of methane produced by the elite or high EBI cows, so the high genetic merit cows, because they're more productive, the calculation model for methane emissions actually predicted them or calculated them to have significantly higher methane output compared to the national average group, where there was no difference in terms of the actual measured emissions. So this suggests that carbon footprinting tools or inventory models, there's potentially a bias there that is overestimating the methane output of higher genetic merit animals because of their increased productivity. But this may not be the case in reality. So this is the first study we've done this, and we're looking to validate this further in future studies to evaluate the effect. The last area then, just to talk about, is it may also be possible to directly select animals for lower methane emissions in the future So there's phenotypic variation or individual animal variation for methane emissions between individual cows. So within all our experiments we do, we see there's high and low emitting cows at a similar level of production and consuming the same amount of grass. So for instance, in the graph here, or in the pictures here, you can see there's 100 grams in difference between those two cows. We have two big questions then: is how much of the variation is due to genetics, so how heritable is it? And then the next thing is, can it be measured on farm? So if it is due to genetics, some of the variation, which is likely is because it's a heritable trait indoors, and if it can be measured on farm, so you can get phenotypes for it, then you could potentially select daughters of bulls for lower emissions in the future. So that's an area that we're looking into as we kind of collect more data and looking into also developing tools to measure methane emissions so on farm, so we can phenotype cows for breeding purposes. So that's the end of my part of the talk. So Hazel is going to continue with the additive aspects, so the primary area.
So I suppose when we were designing the research program here in Teagasc, we, I suppose, talked about what we wanted from a feed additive. And we needed the additive to have a consistent methane reduction potential, so it works throughout the day, throughout the year. And something I suppose that we kind of overlooked initially was it has to be capable of being delivered to the animal. And I suppose most of the research to date has been done in indoor systems where it's very easy to feed additives to animals because they can be mixed through a TMR. It's much more difficult in grazing systems. We have to be able to account for it in the national inventory so that farmers can get credit for feeding these additives to reduce their emissions. There can be no food safety or residue implications or transfer of the additives to the milk. It can't affect performance, so milk production. If there's issues in terms of palatability of the additive, that can also cause problems. It would be very desirable if the additive was of low cost, which is probably unlikely. If it increased animal performance, because that would be an easier sell for farmers. If the additive was of natural origin, I suppose that would eliminate the concerns in terms of food safety and residue implications, and if it could be used in combination with other solutions. So the solutions that Ben talked about in terms of the good quality grass or feed and the, I suppose, genetically superior animals. So if additives worked in combination with those solutions, that would be a win-win. So in terms of our program of work in Teagasc then, we, of course, measure methane in these studies to make sure that the additives do in fact reduce methane. We're trying to come up with solutions to deliver the additives to the cows, both during the winter housing period and at grazing. In all of our studies, we test the milk for residues to ensure there's no transfer to the milk. And we also monitor animal performance, so milk yield, milk solids, body weight, body condition score, and some health and welfare measurements as well. So we've tested lots of additives to date, some of which have shown no impact, some of which have shown significant promise. And while we're looking at additives in both the winter housing period and the grazing season, I suppose our ultimate focus is to find an additive that's compatible across the year and mostly during the grazing season, which is where most of our cows would graze for about 200 or over 200 days a year. So we need something that's going to work during that time. So I'm sure you're all familiar with the lots of research that's been done to date. I suppose, as I said, most of it has been done in indoor systems. And I suppose the two main additives that are often talked about are tree-nop or trinitrooxypropanol and seaweeds, in particular red seaweeds such as Asparagopsis. And they've shown to be really effective in all the different studies that have been undertaken. But I suppose most of these studies were undertaken in indoor systems. So this is a review of all the different available additives that was undertaken by a group in New Zealand, and it ranks the additives in terms of their methane reduction potential. And you can see the two top ones are, as I said, tree-nop or trinitrooxypropanol, or it works under the trade name Bovaer, or Asparagopsis, which is a red seaweed. And I suppose these have been shown to have very high methane reduction potential. There's been lots of papers written on these additives. I suppose, as I said, most of these studies have been undertaken in indoor systems. So we did the first study on 3-nop during the grazing season in the summer of 2022. It was a 10-week trial, and we fed the additive to the cows twice a day. So as you can see in the picture, we had to feed the additive to the cows using buckets. So we had to weigh out 6.8 grams of 3-nop in the morning and 6.8 grams in the evening, and it was mixed with about 500 grams of a coarse ration and fed to the cows in the buckets, as you can see in the picture. And how this works is the enzyme, or the additive, blocks an enzyme called methyl coenzyme M from binding carbon dioxide with hydrogen in the rumen, and that's how it reduces methane. And it's been approved for use as a feed additive in the EU since 2022. So I suppose this is some of the results that we saw. So I suppose prior to undertaking the study, the additive company had told us that the additive is only effective for about 2.5 to 3 hours after it's consumed by the animal. And I suppose what we found just really proved that. So you can see once the cows consume the additive, or within the first 30 minutes, the additive reduces methane by over 40%, and that gradually diminishes then until about 3 hours after consumption, when the effect ultimately disappears. And you can see that clearly in this graph. So you can see the red line is the cows that consume the additive, and you'll see that dips down twice, and that coincides with what you've seen in the previous graph. So it's only really effective for about 6 hours a day when we fed it twice a day to cows on exit from the milking parlour. So overall, there was about a 6% reduction in methane. So I suppose what this trial showed to us was that there are serious questions to be answered in terms of the practicalities of feeding these additives on farms, or on pasture-based farms, and that if, I suppose, 3-nop is to be used on pasture-based farms during the grazing season, there needs to be some sort of a slow release mechanism, or a way of feeding it at additional time points throughout the day, and not just when the cows are being milked. And I suppose since then we've done a couple more studies on 3-nop. So another study we did in November of 2023 was, I suppose at that time of the year, the grazing conditions are suboptimal. So cows are often housed by night and fed a diet of grass silage, and while they're out grazing then during the day, to, I suppose, keep an element of grass in their diet in late lactation. So we did a study where we had a group of cows out grazing together by day, and then by night they came into the shed, and half the cows were given silage that contained 3-nop, and half of them were given silage without. So when we fed the 3-nop in this way, we got a 12% reduction in methane across the day. So you can see the graph shows their methane, the diurnal variation in their methane. And during the day when they were out grazing, when they didn't have access to the additive, you can see there's very little difference between the treatment and control cows. But as soon as they come into the shed and the treatment cows have access to silage containing the 3-nop, their methane is much lower. We've shown really good success in terms of feeding 3-nop during the dry period. So we did a study in 2022 when we mixed the additive through a silage diet using a mixing wagon, and the animals had access to the silage throughout the day. So over the 8-week dry period, we saw a 22% reduction in daily enteric methane, which is really positive. And I suppose what we know is not every farmer has access to a mixing wagon or a diet feeder, so we wanted to simulate a situation where the additive would be mixed in with the dry cow minerals and dusted onto the silage twice a day, which is what most farmers around the country of Ireland would do. So in feeding the additive in this way, we saw an 11% reduction in daily methane. So I suppose what we know is it is possible to feed additives, or I suppose 3-nop, in both the grazing season and the winter housing period. And I suppose its efficacy then depends on how it's fed, either whether it's mixed through the silage using a mixing wagon, or if it's dusted onto the silage. Another additive that we have tested that I suppose we didn't have much success with was a calcium peroxide based feed additive. It showed a 13% reduction in enteric methane, but it also reduced feed intake and milk solids. And I suppose the reason was there was issues in terms of the palatability of the additive. There was a huge quantity of the additive required to actually reduce the methane, and the cows didn't like the taste of it. There was lots of refusals and things like that. So I suppose it's just important to note that there are trials that don't work, and that there is this additive has shown promise in an indoor system in terms of when it was fed to beef animals, but in terms of the cows who were grazing, it didn't really work. So it needs to be tailored to work in that sort of system. And another additive we've tested is the Asparagopsis, or red seaweed. This seaweed grows best in warm water, and they have shown some success in terms of growing it in tanks on land around the world. So what we did was we fed freeze-dried milled Asparagopsis meal to the cows twice a day on exit from the milking parlour. So the cows didn't really like the taste of this. We tried molasses, we tried some flavour enhancer to try and improve the taste of it, but there were some refusals in this study. In this study, I suppose we had to keep the seaweed in the freezer until it was used, and that's just, I suppose, to ensure that we were given this the best chance of working as possible, because it is sensitive to light and it's sensitive to heat and different things. So we wanted to be sure that if it was going to work, it was because we had done everything possible to keep it in the optimal conditions. So as you can see, just some preliminary results here. So we had two different feeding rates in this trial. We had cows who were given a low dietary inclusion of seaweed and a high. So the low dietary inclusion of seaweed, the cows had 20 grams per day of seaweed, so 10 grams in the morning and 10 grams in the evening. And the high cows had 40 grams per day, or 20 grams in the morning and 20 grams in the evening. And as you can see from the graph on the left, there's actually very little difference in terms of the two groups of cows in terms of the methane reduction. And this was because the high cows, the cows that were offered more seaweed, had higher refusals. So they didn't actually, in reality, they consumed a similar amount of seaweed, the cows. And those, I suppose, both groups of cows had some feed refusals. The high cows had more, refused more of the feed, or more of the Asparagopsis and concentrate mix than the low. And I suppose this is reflected in the milk solids then. So there was a slight reduction in milk solids in both the low and the high cows, and I suppose most of this is likely due to the refusals of the Asparagopsis and concentrate mix. So those cows were getting nearly a kilo a day less concentrate than the control cows. So that will provide some explanation as to why their milk solids were lower. Then when you express methane on a per kilo of milk solids basis, there was between 14 and 16% lower. So it was a success. I suppose what it did highlight to us was there are issues in terms of the practicalities of feeding this on farm, and that maybe going forward we need to include the additive in a pellet to make it easier for farmers to feed. And what we did for this study, and what we do for every study in Teagasc, is we take extensive milk samples to look at the quality of the milk, the transfer of the additive to the milk in terms of the residues, and whether including additives in the diet of these cows can impact the processability of the milk. We also look at dry matter intake a couple of times throughout each trial. We measure body weight and body condition score weekly. All the cows are wearing collars to look at their grazing behaviour, and we also take rumen samples and blood samples, I suppose, to give us a greater picture of why the additives are working and how they're working in terms of their impact on rumen conditions. So as a follow-up study then, after the first Asparagopsis study, we did a trial in which we incorporated the Asparagopsis into concentrate pellets. And I suppose this was done with a view to making them easier to feed on farms. So I suppose all of these studies that I've talked about are proof of concept. If we want to get these working on farms, or if we want farmers to implement them, they have to be foolproof, they have to be practical to feed. So ultimately an additive will have to be included in the likes of a concentrate pellet, or fed in some other way that's easy for farms. So we incorporated the seaweed into a pellet in the feed mill during the pelleting process to see how that would work. And we, I suppose, targeted an inclusion rate of 25 grams per day of the seaweed within the pellet. What we saw was there was a 15% reduction in methane in the cows that consumed the pellets. So based on the, I suppose, targeted dietary inclusion rate of the seaweed, we were expecting reductions of, I suppose, closer to 30% in methane based on that. What we did see was only 15%. So we're guessing that about half the seaweed or the bromoform in the seaweed was damaged during the pelleting process, which there's a lot of heat and pressure involved. So that we're guessing that some of the seaweed was damaged. However, we still saw a 15% reduction, which was really positive. And unlike the first trial, there were no refusals in this trial. So it's likely that I suppose, pelleting or incorporating the seaweed into the pellets masked the flavour, the taste of the seaweed, which was really positive. So I suppose at the back of this, we need to do more research to how we protect the seaweed or the Asparagopsis during the pelleting process, and to, I suppose, continue investigating residues to make sure that there's no transfer of the additives to the milk. And I suppose Ben touched on the AgNav previously. I suppose it's really important that if farmers are to use these additives on their farm, that they can get credit for using the additives. So AgNav is a really good tool for the farmers to quantify their emissions and, I suppose, to quantify their emissions reductions based on the technologies that they can implement. And I suppose in terms of future additive research, then we hope to continue evaluating promising feed additives in terms of their practicalities of feeding them on commercial farms with the likes of Treenop, to maybe look into a slow release mechanism. The cost of the additives is a big question, and I suppose with that, developing a business model of who's going to pay for these additives going forward. And with the, I suppose, likes of some of the feed additives, we probably need to do a life cycle assessment, especially if the methane reduction is lower, such as the Treenop in grazing. So it's only about 6% at present. So we need to look at whether the emissions produced in terms of creating that additive and transporting it to the farms outweigh the emissions reduced by the additive itself. So that's everything that we have. So we'd be happy to take questions if anyone has anything.
Thanks a lot. I just turned my microphone on. Thanks for all this interesting information, Ben and Hazel. We have a few questions in the chat. The very first one is asked by Jérémy Desfrères. Were you able to link this methane emission decrease during spring with the high content in unsaturated fatty acid in the grass at the same period? We managed to study this.
Yeah, no, it's a very good question, and yeah, it's definitely something that we think would be a possibility in influencing this result. So yeah, we've looked at the pasture quality in terms of the NDF and digestibility in the crude protein, and a lot of these maybe give some indication but don't explain everything. So that's one thing we haven't looked at yet. We hope to look at it this year, actually, looking at the fatty acid profile of the pasture, and see if that can explain more of the variation. So it would be it would make sense if that was partly related to what was occurring. Yes.
And this is my additional question here, related to the very first webinar we made about prediction. Did you manage to use mid-infrared spectra or other milk analysis like fatty acids to predict also methane emission and make the comparison with your measures using green feed?
There has been a paper published, yeah, looking at MIR predictions of grazing. So Sinead McParland and Donna Berry, Maria Frizzani would have done it, and they would have found that at an individual animal level, it gives a okay accuracy, moderate accuracy. We haven't really looked at it at a herd level, but it looks like it has shows some promise with phenotype in individual cows. Yes.
Okay, great. Perfect. I think we are all working the same way in different countries, so it's good. Second question from Megan Harmon. So just to understand, more efficient animals effectively dilute the level of methane emissions. Is that right?
Yes, so more efficient animals can, it's generally observed that as an animal, as you increase feed efficiency, improve the amount of product produced per unit of feed eaten or intake, you will dilute the amount of emissions produced because you're producing more production per kilo of intake, and as a result, you're producing less methane per kilo of milk output. Then, as a result of that, so that's generally the observation we would see.
And also an additional question from myself: do you have any other result that suggests also that efficiency could also improve fertility and longevity of animals, or not?
It's an interesting question. Yeah. So if you improve feed efficiency on an individual animal level on a daily basis, you're getting the animal to maybe divert some of the nutrients away from reproduction, from maybe body condition score and fertility into milk production. So sometimes that can work against you on a system level because the cow maybe mightn't go back and calf as easily, and as a result of that, she mightn't last in the herd as long. So there are some trade-offs there in trying to improve system level efficiency and individual animal feed efficiency. But if you have a balanced breeding objective with the traits adjusted accordingly, you should be able to select for the two simultaneously.
Great, thank you. Third question from Katalin Dragomir. First of all, she thanks you for the presentation, very interesting. And what is the primary goal for the Irish farmers' point of view of including methane reduction additive in the diet? Is it climate or efficiency? Which is the first mentioned benefit in the primary discussion with the farmer?
Hazel, do you want to take that question?
Yeah. So it's definitely, I suppose, reducing emissions. We haven't really shown any efficiency benefits really. So it is in terms of reducing emissions, but I suppose we're very far away from actually being at a point of actually rolling these additives out on farm. We did a pilot study on a small group of the signpost farms where we fed the tree nop during the dry period or the winter housing period. And it was, I suppose, just to see how the farmers got on, if they had issues in terms of feeding it, if it took time, or if it, how easy or difficult it was. And I suppose it went well from the point of view of, we got their feedback, and they said they'd be happy to feed it again. But I suppose their big thing was the cost of who was going to pay for the additives going forward. So I suppose before we can even think about the reasons why farmers would include these additives, it's who's going to pay for the additives. So that's a big conversation that needs to be had.
And Tom O'Dwyer added in the chat also that farmers will use feed additives only if the cost is covered anyway. Yes, and that's exactly the same all around Europe, I guess.
Yeah.
Another question about Asparagopsis from Marc Offray. Asparagopsis is mostly coming from Australia, but not Europe. A life cycle assessment analysis will be interesting to determine if red seaweed is a sustainable option. Do you have any comment on that?
Yeah, well, I think traditionally, most of the Asparagopsis did come from Australia. It's an Australian company that licensed its use as a feed additive, Future Feed. But the seaweed that we used as part of this trial, I think, was grown in Sweden. And there is a research institute based in Ireland that are also in the process of growing the Asparagopsis in tanks on land. So it's a difficult seaweed to grow. I've been down in their institute. Like, there's certain light conditions, heat conditions. So at the minute they're trying to, I suppose, optimize the product to produce a seaweed that has a consistent bromoform concentration or of a consistent quality. So they're working on that. So I think going forward there will be, I suppose, seaweed produced. It is possible to produce it in every country, if they can come up with the right conditions. But yeah, I agree that even still, life cycle assessment should be undertaken for all of these additives.
Thank you. I think we have two more questions. The first one is from Sophie Bereux. Was there an impact on the milk performance with the pellets of Asparagopsis?
No, there wasn't. So with the pelleting study, there was no difference in the milk between the treatment and control cows, which is really positive. So I suppose at the minute we just have the milk yield and the milk solids data. We did take more intensive milk samples, but this trial was only done just before Christmas, so we're still waiting for some of the results from the, I suppose, more intensive, the fatty acid profile and things like that. But in terms of the milk yield and the milk solids, there was no difference between the treatment and control cows, which is really positive.
Okay, thank you. Another question from France, Florence Bedouin. She's asking, did you make any study about the acceptability of the different additives by farmers? And what about acceptability by society, consumer? Do you have something in debate in Ireland on that topic?
No, and I suppose that that's something that we probably do need to do. I'm sure you're all aware about the I suppose consumer perception of 3-NOP or 3-NOP before Christmas, and that did really highlight to us that that maybe the consumers would have an issue with these additives, and maybe a more natural additive would have better consumer perception. I suppose we get a lot of groups of farmers and researchers and different people from all over the world coming to Moorpark, and with all of the people that we've talked to, most of them are pretty accepting of the additives. I suppose they see the science behind it, but in terms of the general public, yeah, it's probably something that does need to happen. Some sort of a survey or something like that on consumer perception.
So on that topic, I know that Florence has some result in a European project about the perception of this, and maybe it could be interesting to organize this exchange.
Very good.
Another question from Stephen Archer. Would it be worth trying to target methane reduction in younger animals before they join the milking herd? What's your view on that?
Do you want to take that one, Ben?
Yeah, it depends on what the strategy is. I suppose maybe if you're looking at an additive to go into the system as younger animals, it needs to be a practical way of delivering, especially in a pasture-based setting. So, you're looking at bolus really technology there to get, sustained reductions. And if you had a breeding value for lower methane emissions, then, you'd hope that it would work equally well as on a lactating animal and on a growing animal, across the different stages. So, I think, yeah, we definitely should be targeting reductions across the production system and to look into practical solutions to try implement those.
Okay. We also have one comment about from Tom O'Dwyer. This is also the choice we made in France. We are not using the term additive anymore. We are using the term supplement. And it's also interesting to have this different word for all this process, especially for society and consumer. So the proposal of Tom is that the term additive might even be off-putting for consumer, and perhaps supplements or other terms might be more acceptable. So this is something for the future. And I'm sorry, but it will be the very last question for today from Valentine Landais. As it is already developed by CAP in Europe with ages, could farmers get grants for the effort to reduce their methane emission on farm in Ireland? Is it considered? Is it already in place?
I don't think so. Maybe Ben, you know more about it, but at present, I don't think there's any grants.
No, there's no grant at the moment, yeah, for supplementing additives. So I suppose it's important, like the likes of the research that Hazel has done in the grazing settings. That's all kind of found, really, looks into take a step further and look into economics of it and what's the costs of it and all that. And after that, then you can look at how it will be implemented, or and the best ways of doing that through grants or any other means.
Okay. Thank you for all these answers and all the questions of the participants. We have two last things to do. The first one, I would like to thank you, Ben and Hazel, in the name of all the participants and the Climate Farm Demo project. It was really interesting and innovative results we were waiting for. So now we will also be able to address more issues about feed additives on pasture. So maybe for the future, we could also keep in touch for the next results to come. The last thing to do for all the participants will to answer the survey, the final survey. So please take these few minutes to tell us if you're satisfied or not, and what could be done differently or could be done in the same way. So the survey is open. You can answer now. And while people are answering, just a reminder that this webinar was recorded. It will be sent to the participant after this event, and you will be able to find this webinar and all the webinars of both Climate Farm Demo and Climate Smart Advisors on different topics in the YouTube channel of Climate Farm Demo. I put the link in the chat at the very beginning of this webinar, and I will put it a second time now, so you will be able to find all this material. Okay, Susanna, I think we can close the final survey. So once again, thanks to all the participants for the questions of during this webinar. Thanks once again to Ben and Hazel for their interesting contribution. And I can say that more webinars will be organized in the future on this specific topic of methane and feed additives. So stay update, and we will try to spread the new themes as soon as it will be organized. Thanks once again, and bye-bye. Have a nice day.
Thanks, everyone.
Bye.
Bye-bye.